Good morning, students. Today we'll discuss about the chemical properties of carboxylic acid. In last class we have done about the acidity of carboxylic acid. So today we'll discuss about the reactions of carboxylic acid. So number one reaction with active metal. Active metal means the reactive metals. Sodium, magnesium, potassium, these are said to be the reactive metal, active metal. Carboxylic acid, when reacts with metal like sodium, you know the property of acid. When acid reacts with some metal, it produces salt and releases hydrogen gas. So this hydrogen will be removed from it and it produces salt like this, RCOO Na. Here RCO is minus, Na is plus, and this is called sodium salt of carboxylic acid, plus half of H2. To balance hydrogen, I put half here. So when carboxylic acid reacts with sodium metal, it produces salt which is called sodium salt of carboxylic acid, and it releases hydrogen gas. And this is one of the property of acid. Any acid when reacts with metal, it produces salt and hydrogen gas. Similarly, carboxylic acid when reacts with magnesium metal, as you know, sodium valency is 1, magnesium valency is 2. So when it produces the salt formula will be like this, RCOO whole to Mg. This is called magnesium salt of carboxylic acid, and it releases hydrogen gas. Due to magnesium valency 2, you have to apply 2 carboxylate ion. So to balance it, you can put 2 here. Then hydrogen will be 2, so no need to put half here. Like this way you can balance. So this is about the reaction with metal. Number 2, simple reaction. Reaction with alkali, base. Sodium hydroxide or ammonium hydroxide. As you know, these are bases. And you know, acid when reacts with base, what it produces? It produces one salt and water. So this is carboxylic acid. When it reacts with sodium hydroxide, acid reacts with base to produce salt. The salt will be sodium salt of carboxylic acid, and here side product will be water. As you know, acid release H plus ion, base release OH minus ion. The OH minus ion combined with H plus ion, it produces water. So when acid base reaction takes place, always you will get salt and water. Similarly, we take one example. This is what benzoic acid. C6H5 means the benzene ring. When benzene ring contains COH group, it is called benzoic acid. When it reacts with your sodium hydroxide or ammonium hydroxide, then also it produces salt. The salt will be like this, C6H5COO NH4, which is called ammonium salt of benzoic acid, and side product will be water. So any carboxylic acid you can take, ethanoic acid, methanoic acid, benzoic acid. When it reacts with base, it produces the salt and water. Number 3 reaction, this is important. Reaction with sodium carbonate or carbonates and bicarbonates. Reaction with carbonates and bicarbonates. This reaction is important. If you consider acetic acid, suppose this is your carboxylic acid, any carboxylic acid you can use for this reaction. When it reacts with sodium carbonate, the acid can decompose the sodium carbonate and it releases carbon dioxide gas. To first time you will get a salt like this, CH3COONA, sodium salt of carboxylic acid, and it undergo a decomposition of sodium carbonate and it releases carbon dioxide gas. You will get the effervescence of carbon dioxide gas and it releases water. Similarly, if you take benzoic acid, for example, and when you react with bicarbonate, NaHCO3, bicarbonate means sodium hydrogen carbonate, then it also produces salt C6H5COONa, which is called sodium salt of benzoic acid. It also releases the carbon dioxide gas, and side product will be water. And this reaction is used as a test for carboxylic acid. We have done in practical functional group detection. So a compound contains COOH functional group or not. To identify that, always you add sodium bicarbonate or sodium carbonate. When you will get the effervescence of carbon dioxide, effervescence means you will get the bubbles. When you get the effervescence of carbon dioxide, that means your acid contain COOH functional group. Yes, alcohol or acid, phenols are also acidic, but phenol, alcohol, they cannot decompose sodium carbonate to produce carbon dioxide gas. Only this carboxylic acid can decompose sodium bicarbonate, sodium carbonate salt to produce the effervescence of carbon dioxide gas. And this reaction is used as a test for carboxylic acid functional group. So in practical also you have done it. You apply sodium bicarbonate, then you have got the effervescence, and like that way you find out your compound contain carboxylic acid. Now another reaction. Carboxylic acids reactions are simple. Another reaction which is called formation of ester. Formation of ester. This reaction is also called esterification reaction. Very important reaction. And mechanism also required for this reaction, esterification reaction. Here in this reaction, ester will be produced, the sweet smelling organic compound, and due to formation of ester as the product, the reaction is called esterification reaction. The reaction is like this. This is one carboxylic acid RCOOH, and this is one of the alcohol ROH. To distinguish the R, you can write R dash. When carboxylic acid reacts with alcohol, this reaction is reversible and acid is required to carry out the reaction. H plus means it represents acid. Then this carboxylic acid release H plus and alcohol release OH minus N to produce water, and the product you will get like this RCOOR dash, and this compound is called ester. So when carboxylic acid reacts with alcohol in presence of acid, it produces ester and water, and that's why this reaction is called esterification reaction, because ester is produced. This reaction is reversible. You can do the reaction in backward direction also. When ester reacts with water, again it can produce carboxylic acid and alcohol. That is why one question asked here, what is the name of reverse reaction of esterification? This forward direction is called esterification reaction, but if you want to write the name of backward reaction, then you have to write the name of the reverse reaction of esterification is hydrolysis of ester. Because you know, when some organic compound is added with water, that reactions are called hydrolysis reaction, and that's why the reverse reaction, I mean backward direction reaction, is called hydrolysis of ester. For example, this is your acetic acid, and suppose this is your alcohol, ethanol. When this carboxylic acid, acetic acid reacts with ethanol in presence of acid, then the product you will get like this. I mean you will get ester, CH3COO C2H5. Hydrogen combined with OH to produce water. Do you know how to write the IUPAC name of ester? To write the name of ester, this is 1, this is 2, like this you have to numbering. Since oxygen is present here, that's why you cannot numbering this carbon. So 2 carbon you have got, that's why ethane, and this is your ethyl group. So the name is written like this, ethyl, I mean for this group, and this is 2 carbon means ethane, and for ester, you have to apply the suffix oate. That's why ethyl ethanoate. Like this you have to write IUPAC name of ester. This is your ethyl group, ethyl ethanoate. Similarly, this is your ester. If you want to write the name of this is your methyl group, na? So methyl, 2 carbon present here, methyl ethanoate. So this is the process how to write the IUPAC name of esters. You will get when you study your amine compound, then also you will get the esters. Now for this reaction, the mechanism is required. The mechanism is very important for exam. You will get the question like this, write the mechanism of esterification reaction. So now I will show you about the mechanism of this esterification reaction. I mean how carboxylic acid reacts with alcohol to produce the ester. So when you draw the mechanism, already you have drawn so many mechanism. Always you try to write the mechanism in step by step, then you will get the full marks. So here also I try to write the mechanism in step by step, and this mechanism is especially very important for exam. So that's why you try to learn the mechanism. Okay, then in next video we will do this mechanism. Thank you.